Let's take a look at the app you are going to make first. A number is displayed in the middle of the screen, which increases or decreases each time you press the plus and minus buttons in the lower right corner. Also, when the number becomes 3, a dialog box is displayed, and when the number becomes -1, it moves to other page. Let's make a Cubit version and a block version. For most of the apps we'll make in this tutorial, I'm planning to make not only Cubit version, but also block version so that you can get used to them quickly. To save time, I created an app called My Counter Cubit and installed Equatable and Flutter Bloc. And by commenting include line of the analysis options.file, the default renting rule will not be applied during the development process. It's a simple app, so let's start by making the skeleton of the app in advance. Let's start with main.dart. Title is My Counter Cubit and hide the debug banner. I deleted my homepage, which was originally a stateful widget, and created a new one as a stateless widget. My homepage consists of a text widget and 2 floating action buttons. The text widget displays a 0 or font size 52.0, and the unpressed callback of floating action buttons are empty functions. Next is other page.dart. The other page widget is a simple stateless widget that displays other in the middle of the screen with font size 52.0. First, we'll make a Cubit. After creating the Cubits folder under the lib folder, we'll create templates using the block extension. Right-click on the Cubits folder and select Cubit, New Cubit from the displayed menu. A box will appear asking you to enter a name. I will type counter. Then a Cubit folder is created under the Cubits folder, and at the same time, 2 files, counterstate.dart and countercubit.dart, are created under the Cubit folder. There is no need to change the name since we are going to make one Cubit at the moment, but if we were going to make multiple Cubits, we need to make the name clear. I will rename the Cubit folder to counter because the Cubit I made is a Cubit related to a counter. First, let's look at the counterstate.dart file. An abstract class called counterState that extends Equatable and a class that extends counterState called counterInitial are created. When you create the Cubit using the block extension, the state is basically created in the form of a class that extends Equatable. However, if the state is a primitive type such as integer or string, you can process it without creating a separate state class. However, if possible, I create and manage all state in the form of a class. The advantages of doing this are maintaining consistency and avoiding type conflicts. We'll talk about avoiding type collision in detail later. But when finding the data you need in Flutter Bloc, it climbs up the widget tree and finds data with the same type. At this time, it finds the closest data on the widget tree. So if the type is the same, it cannot find the data that is farther away. In this case, if you make the data into a separate class, you don't need to worry about type conflicts. Let me give you a brief explanation of the Equatable package. Assuming there is a class A, create 2 instances of class A, A1 and A2, and print whether A1 and A2 are the same, and false will be output. If you want the result that A1 is equal to A2, you have to override the equality operator and override the hash value of the class. Often, when creating an app, you need a criterion for when 2 objects are equal. It is quite cumbersome to have to override the equality operator and hash value every time. But Equatable is a package that lets you not have to worry about that. Bloc uses Equatable's equality check function to ignore the new state if the new state is the same as the previous state. Equatable packages are extensively used in Bloc and often used with .data class generated extensions. See the MI section for Equatable and .data class generated extension. If you are unfamiliar with Equatable and the .data class generated extension, be sure to refer to the MISC section. Let's take an example of how the Flutter Bloc package assumes by default when a new Cubit is created using Cubit.newCubit in the menu. Let's assume that the counter value is stored in a remote database. Then let's think about what kinds of states need to be processed in relation to counter value. The block extension creates an abstract class that extends Equatable called the counter state. The rest of the state extends the counter state class. You need an initial state to show to the user. Make this state a class called counter initial. If you read the counter value, you need to show that the counter value is being read. Make this state a class called counter load in progress. If reading the counter value fails, you need to show that it failed. Make this state a class called counter load failure. If the counter value has been read successfully, you need to display the read value. Make this state a class called counter load success. The method of processing each of these as a separate class is a method that block extension handles by default. My preferred method is create and use the state that's used in one qubit or block as a single class. If it is necessary to express a specific status, such as loading in the state, create and manage a separate enum. The advantage of configuring the state in this way is that when an error occurs, when you want to configure the UI in a way that still shows the previous data, it can be implemented easily because you can access counter and error at the same time. You can use the state.copy the function to keep the previous counter value even if an error occurs. When using the copy the function, a new state is generated every time, and for a value not given as an argument, a state with the previous value is created. For example, let's say you have a count state where counter status is counter status.initial, counter is 0, and error is an empty string. At this time, if only counter status, where the counter status value is counter status.loading, is given as an argument to the state.copy the function. The generated state is counter status.loading, counter is 0, and error is an empty string. That is, the previous value is maintained for the value not given as an argument. You will get used to it quickly as this method comes up over and over again. So I'll delete all the existing content of countState.dart and create a new counter state in the same way as I just said. Create an integer type final variable counter. Next, run the generate constructor menu of the .data class generate extension to create the constructor and run generate Equatable, generate toString, and generate Cubit in order. And delete the Equatable import from the path file counterState.dart. And we will create a factory constructor called counterState.initial to use as the initial state of a counter state. The counterState.initial factory constructor returns a counter state instance with a counter value of 0. Now that we have created our count state, let's go to the counter Cubit.dart. The code, as you can see, was already created. Put the factory constructor counterState.initial. We create a counter state instead of a counter initial. Every qubit is given a state variable and an emit function that emits the new state to a stream. So the state of counter qubit becomes an instance of a counter state. And if you need to access the counter value, you can access it in the form of state.counter. And new counter state can be created using counter state's copywith method. The copywith method creates a new state without mutating the existing state. When you create a new state every time, there is the advantage of making it easier to track the state. Now, all we need to do is create a function that you can call externally. First, the increment function that increments the counter. Using the copy the function of the state, create a new state whose counter value is the value of adding 1 to the counter value of the current state, and then emit it. A decrement function that decrements the counter. After using the copy the function of the state, the counter value is a new value obtained by subtracting 1 from the counter value of the current state, and then emit it. You have done all you have to do on the qubit side. Now it's time to work on the UI.